population in Delaware County was 109,000 in the year 2000, and it's projected to be 230,000 in the year 2025. And that's a true source there. Assuming population is compounded continuously, determine the rate at which the population is growing in Delaware County. Again, as you're reading through these problems, pick out the most important words. And in this particular case, the most important words are compounded continuously. When it says compounded continuously, that's our formula that we need to use. The PE to the RT. As we take a look at this one, it says, what is the value of T that you will use? Well, it starts here in this problem. It says the population in Delaware County in 2000. And the question eventually is going to be, well, what's it going to be? Well, in 2025, it's going to be 230,000. Well, how many years between the year 2000 and the year 2025? That would be 25. Just a little bit of work. Since I stumbled, 2025 minus 2000 is where I get the time of 25. Other things that we know here is it says that the population of Delaware County was 109,000 in 2000. That's our P. 109,000. Well, then it says in 2025 it's 230,000. That's our A. Assuming that the population is compounded continuously, determine the rate. We want to find R, and we already know from part B that our time is 25. So we're going to fill in this formula. What we get 230,000 equals 109,000 times E, and we need to make sure that we know where E is on our calculator, to the R times 25. If you've been working through all of these problems here, what you've seen is that we need to isolate. And we're going to divide both sides by 109,000. And we'll try that on our calculator. It's not going to be pretty, but we are going to be left with E. And instead of R times 25, I'm going to write 25R. You do not have to do that. It won't make any difference. But over here, let's type in 230,000. 230,000 divided by 109,000. We'll get this. Which, if we're going to use this number, we have to write it down every single time. So let's see if we can convert it to a fraction at least to make it a little bit simpler on us. And once again, the buttons that we're going to press are math, enter, enter. So it's a little bit easier if we use 230 divided by 109. 230 by 109. You don't have to, on this problem, use ln, the natural logarithm. I am going to use ln because there's an E in this problem. If you love log, use log. It will work just fine on this problem. The reason why I use natural logarithm is because there's an E in this problem. You can use log every single time. You can use ln every single time. But I'm going to put in an ln on both sides. So we still have our E to the 25R. And over here we've got our 230 divided by 109. We're going to take our exponent, which is where the variable is, and why we have to use logarithm in the first place. Because we need to get that variable out of the exponent position. So we're going to take this value of 25R, we're going to write it out in front. And now what we have is that the natural log of 230 divided by 109 equals 25R times the natural log of E. Now if you really look, the natural log of E is 1, which is ultimately why I choose to use this. But I don't want to change up any method, any way that I've been doing all the previous problems. So eventually we want to solve for R, and we're going to start by dividing by the natural log of E. And I'm going to type that in to the calculator. So we have the natural log of 230 divided by 109, close the parentheses, divided by the natural log of E. Your E button is on the division button. Second division gives us the E. Once again, we have this decimal here. 0.746 is what I'm going to write down, but leave that number in your calculator. 0.746 equals 25R. Because we're trying to figure out what the rate of this is, but it's 25 times R, so we're going to divide both sides by 25. And we don't want to get a rounding error, and that's why we want to leave that number in the calculator. Dividing by 25. This is what we're going to get when we have that in our calculator. We end up with our rate. It's going to be, and we've seen this before here, 0.0298 actually rounds to be 0.030. And then finally here, what we really want to know is express the rate as a percent. Well, to express it as a percent, we need to move our decimal back to the right 2 spaces, and that means that we end up with a 3% for our rate.